Greetings, this is Dr. Derek Ong with the continuation of the statistical analysis using SPSS. In my last video, I have shown how to do reliability analysis for multi-item scales. That is where I have put in the variables which I note that are important to the items that are important to my variables. So what I'm going to do now is, after I have done my reliability, I would then take my questionnaire and distribute it to collect my data. And once my data is in, I need to do a factor analysis, or more commonly the confirmatory factor analysis, to ensure that my factors are good factors represented. So what I'm going to do is, I'm going to take this and do my factor analysis into the variables. So I'm opening up my mole atmosphere. I'm going to go into analyze, dimension reduction to factor, and I need to know what are my variables here, items here. Now, before this, M6 was part of the music variable, so I'm going to put that item in to show you why I deleted M6. So P1 to P7 goes in, P1 PC1 to PC7 goes in. Next would be IS1 to IS5, IS1 to IS5. Now if you notice that we do this factor analysis by putting in all the items inside, which is unlike our reliability analysis where we do it factor by factor. So please remember this very important step, whereby for reliability analysis we do it factor in the items which belongs to the factor, one factor at a time or one variable at a time. But for factor analysis we put in all the variables of items inside. Okay, so we continue on. E1, 2, 3, 4, 5, 6, 7, 8. So all the employee engagement goes in. Next, music, M1, 2, 3, 4, M1, 2, 3, 5, and we're going to put in 6 because 6 was not taken out in our reliability. So M1, 2, 3, 5, and 6. And 6. We do not put in the variable of consumer behavior because that is a dependent variable. We are only doing two factors for the independent variables. Yeah. So that's done. In our descriptives, we need to see the KMO and Bartlett's test of sphericity to ensure that everything's good. Extraction using scree plots. We're going to use the principal component, and we're going to go by two types here. I'm going to go by number of factors. So I'm going to say that there are 4 factors, and these 4 factors are by theory. So I'm going to go by theory here. Continue. Rotation, I'm going to use varimax. The reason why I'm using varimax is because I'm using an orthogonal rotation. Now, an orthogonal rotation means that I assume that the variables are basically correlated, and therefore when I rotate, sorry, I assume that the items are not correlated, so therefore when I rotate, it will basically give me a much easier interpretation of my variables. But if I were to use an oblique rotation, which is basically direct oblique and varimax, means I will assume that my variables are highly correlated, and when I rotate, it will give me a much better um, definition of what my factors are. But the problem is, it will be a little bit more difficult for me to define what those factors are. So there's always a trade-off between using the orthogonal varimax and the oblique of direct oblique and promax, whereby orthogonal will be much simpler but less accurate, and direct oblique will be a little bit more difficult um, to interpret, but it's definitely much more accurate. So, but for now, let's just keep it easy and just put varimax. Maximum iterations and conversions, you may want to increase this if the convergence of the rotation does not give you a solution, but usually 25 will be good enough. Scores, you don't need this. Options, suppress small coefficients, anything with a loading of less than 0.4 we don't want to see, because then it will confuse us. So press continue, press OK. Now here we have the KMO and Bartlett's. It looks good. Casimir-Oken is above 0.6 or 0.7, and Bartlett's test of sphericity is significant, so we have good factors. Total variance explained is about 50%. That's very, very good, especially for social science. And we want this to show in our scree plot where the bend is. We got 1, 2, 3, 4. And we do not look at the component matrix. What we look at is the final rotated component matrix. As you can see, this is really, really nice. PC 1 to 7 falls into one factor. IS 1 to 5 fall into one factor. EE 1 to 8 falls into one factor. And the M 1, 2, 3, 5 falls into another factor. Now you notice that M6 falls into the factor of the interior setting. So let's look at the questionnaire of M6. There we go. 1, 2, 3, 4, 5, 6. Now, the more music is played at an appropriate volume. So the reason why this is what we call as a cross-loading for M6 is because half the respondents feel that this item is asking about the music, whereas half of the respondents are saying that this item is asking about the ambience. So they really are not sure whether to put uh, the item in terms of its recommendation, whether it should be as a interior setting or a music. So this is going to be a problem with a lot of multi-item scales. So usually the easiest way to deal with this problem is to just not use the item, because we have enough items in our data set. So as long as we have 4 or 3 would be just good enough. So we don't need M6 actually. Okay, so therefore our final items for our factors will be this. So what we do now is to create our summated scales using these items. So let's do perceived crowding first with these 7 items. So we go to transform, compute variable. Let's call perceived crowding, and it's going to be PC 1 to 7. We get the mean value out of PC 1 to 7 because we want we want a long quantitative measure, continuous. So PC1, comma, PC2, comma, PC3, comma, PC4, comma, PC5, comma, PC6, comma, PC7, and comma, and we close. Right, so we have perceived crowding, and if you look at the data, it is on a continuous scale, right? So all you need to do now is to follow using the transform analysis to find all these variables. Let's just do it. What do we have here? IS wants to 5. So let's transform compute variable, interior, setting, mean, IS1, 2, 3, 4, and 5. Then press OK. Next, we have to do for employee engagement. Analyze, transform compute variable, employee engagement. We will do this E1, E2, E3, E4, E5, E6, E7, and E8. So get the mean values for employee engagement. Music is M1, 2, 3, 5. So we do that. Music. M1, 2, 3. Make sure you remember the comma. And 5. Right? And of course, don't forget about your dependent variable, which is consumer behavior. So we do this for CB127. 1, 2, 3, 4, 5, 6, and 7. So once we've got out all 7, and we can literally now use these variables to do our linear regression and hypothesis testing. So please check the video on how to do linear regression, multiple linear regression, um, for hypothesis testing using the hypothesis that you have derived in terms of your framework. Alright, so that's how you use exploratory factor analysis and confirmatory factor analysis to create summated scales from your um, multi-item scales. Alright, so if you have any questions on factor analysis, please do email me, or else thank you very much, and hope you learn something.